All right. So, what is Pythagoras' theorem? You should be more or less familiar with that, and I'm gonna ask you this question: what's Pythagoras' theorem? Do you remember the relationship? If I have this kind of triangle, how do we call this triangle? With 90-degree angle in it. A, B, C, and the Pythagoras theorem is
A squared plus B squared plus C squared.
A squared plus B squared is C squared, right? Is C squared. Okay, good one. You know that, but who can prove that? Why that relationship is actually correct? Do you remember the proof? How to prove it? We'll just spend a few minutes to recall how to prove it. The evidence, the proof is very elegant and simple. So, proof. Let's consider four right triangles. Okay? So, let's say it is one right triangle. Yeah? And I'm going to consider exactly the same second right triangle. Now I'll consider another exactly the same right triangle. And finally, fourth one. And finally, I'll consider fourth exactly the same right triangle. And by having this kind of indications, I say that this side is exactly the same as this one, and they are equal. So by having these things, I say that these triangles are exactly the same. And let me mark the sides. Let mark the biggest side here, that which we call hypotenuse, as C. So this is side C. Let me label this side as B. Let's say this is going to be equal to B. And finally, third side I'll label as A. A, right? A. So now I have four equal triangles. And now I'll combine them together so that they will form a square. So I'll combine them together in this way. So let me take the first one. Let's say here it is. Let's say that is my first triangle, right? And let's say this is my side B. B, this is A, this is C. So that's my first triangle. Now I'll take my second triangle, but I'm gonna locate him in a different way. I'm gonna locate him here. Here it is. Okay, that's my second triangle. So this side is equal to that side. Now this one is equal to this one, and that side is equal to this side, right? That's my second triangle. Now I'm going to take my third triangle and locate him in a different way. I locate him here. All right, and like that. Okay, so once again, that is my side C. My side C, that is my side B, that is my side A. All right, and finally, I'll take my fourth triangle and gonna locate him so that it will complete the square. Okay, so here is my side 1, 2, finally the third one. Okay. All right, so I know that these four triangles are right triangles, right? And they form the perfect square, right? So that again, that is my side B, that is my side, no, that's side A, that's side B, and that is my side C. Let's label them to make it more clear. Okay, that is C, right? This side is C, right? That's clear for everyone. Yeah? Well, how do I label this side? How do I label this side? What? A, yeah. So let's label this as A. A. Here's this. A, right? And finally this one is, the last one is B, right? So let's label it as B. B and B, okay. And now let's ask the question how to express the area of the entire square. So we have no doubt that this figure is a square, right? Because this side is equal to this side, right? So let's express area in terms of A and B, area of this square. So let's say area is equal to what? A plus B, right? A plus B multiply by A plus B, right? A plus B. That's on one hand, right? But on the other hand, I can express the same area as the combination of areas. I can express this area as the sum of areas of those triangles plus area of this square, right? So let's do it. On the other hand, area, the same area, is equal to the sum of those areas. So I have 1 over 2 AB, and how many of triangles I have? 4. So 4 at the front of the brackets represents that I have 4 triangles, right? Plus what? Plus what? C squared, yeah, plus C squared. Okay, good. I can rewrite it as, if I open these brackets, I'm gonna have 2AB plus C squared, right? And since they represent the same area, I can equate them, right? Because they're the same, they represent me the same. So area basically is equal to area, right? So this left-hand side is equal to this left-hand side. So this right-hand side is equal to this right-hand side. So I'll write it down. So basically that is what? That is nothing else as A plus B squared, right? So I can write down that A plus B squared is equal to 2AB plus C squared, right? Yeah. And now what's left to do? It's I can only just open the brackets using the perfect square formula, right? Which gives me what, Amanda? What will it give it to me? What will it give it to? If I open these brackets, what is the result?
A power 2 A 10 A 就 A 的20方我出来，对耶，plus 2AB
Yep.
plus B 方 B 2 square B square.
Yeah, B squared. And it is equal to 2AB plus C squared, right? So as you see, those terms cancel each other out, and all I left is A squared plus B squared equals C squared, right? So basically that's my expression here. That's my expression, right? You see? C squared equal A squared plus B squared, right? Same. So that's my Pythagoras theorem. That's a very elegant, fast way to prove why this one is true. Yeah? Okay. Okay, so in order to have some practice, I want you guys to open your books on page 572 and finish